Intelligence is the art of creating brand new solutions to problems we never had before. We, humans, are very good at that. That's why we are intelligent. Well, in that sense, LLMs are, so far, not very intelligent. Very powerful LLMs can find existing solutions to documented problems. So far, they are not able to find new solutions to new problems. That said, of course, provided that the LLM has seen or has been shown a problem before, it might be able to find a satisfactory solution in seconds. For example, a well-trained LLM can translate from any language to any other language in seconds. For us humans, it takes an initial 5 years at least to learn our own language, and an additional 10 years to learn an additional language, and another 10 years thereafter for each additional language. Give or take, it takes us humans 30 years to learn 3 languages when LLMs can do that in seconds. Worse even, some people can barely speak or write their own language. In that sense, artificial intelligence might seem more intelligent than us, humans. But LLMs are just wordsmiths in the dark. Because LLMs do not understand what they're doing. LLMs do not understand the emotion when they translate from te quiero to I love you. Enter something called the word model. A word model is a crucial mechanism that allows AI systems to understand and navigate the complicated and unpredictable physical environments where many of them will eventually operate. This idea can be traced to a 1943 book by Kenneth Craig, who proposed that living beings maintain an internal miniature representation of the world in their minds, enabling them to test ideas mentally before acting in real life. Actually, we all have a representation on our mind of what the world is. There is even a word for human. It's called BS. Seriously speaking, understanding how the world functions is a fundamental prerequisite for planning how to influence or reshape it. Without such an internal model, any organism would exist in a purely reactive state, simply avoiding harm, seeking nourishment, and doing little beyond immediate responses. There are 3 main approaches being explored to build world models through artificial intelligence. The first one is video-based simulation. One approach builds words model through AI video generation, where systems learn to simulate a coherent environment from visual data and use these simulations to understand physical interactions and train themselves in virtual settings. The second one is the 3D spatial environments. Another method promoted by Fifi Li create fully interactive and consistent 3D digital worlds that represent complete spaces, enabling AI to reason about physical environments more realistically and support multiple users or perspectives. And then the third one is the abstract predictive representations. That third approach is championed by Yann LeCun. He develops word models as abstract predictive systems, such as joint embedding architectures that help AI anticipate outcomes and plan actions across both physical and virtual environments without simulating every detail. More advanced language models probably contain increasingly sophisticated internal representations of the world, if only researchers can uncover how they work. So far, humans are more intelligent than LLMs. They just don't have the huge necessary memory to remember it all. But as language models grow in scale, they may develop increasingly rich internal representations of the world. The problem is that understanding and locating these structures remain a challenge for scientists. In plain English, humans don't understand clearly how LLMs work, though some scientists do. Researchers at Anthropic, for example, have studied the international workings of their cloud systems and discovered organized groups of artificial neurons linked to specific ideas ranging from emotion like guilt to real-world landmarks such as the Golden Gate Bridge. Experiments show that altering these neural patterns, similar to findings from studies involving the game Othello, leads to predictable changes in the model's later output. These results indicate that large language models are doing more than simply predicting sequences of words. They appear to form stable internal representation of real-world objects and relationships and rely on this structured knowledge when producing answers. In that sense, their behavior resembles what one would expect from systems operating with an internal world model. Now, ultimately, if artificial intelligence develops robust world model, it could surpass human intelligence in reasoning, prediction, and decision-making. Such systems may transform science, economies, and governance while challenging human autonomy and responsibility. Society would face profound choices about control, ethics, and coexistence with machines more capable than ourselves in practice. Whatever happens in the future with LLMs, there is little doubt that AI is about to pay the real world a visit. What do you think of that? I will read your comments below.